Chapter 28 is on single-phase transformers, so let's go over the homework. Number 1, what is a transformer? And straight out of the textbook, a transformer is a magnetically operated machine that can change values of voltage, current, and impedance without changing the frequency. And number 2, what are common efficiencies? Yeah, transformers tend to be very, very efficient, certainly in the 90% range, 90 to 99%. Number 3, what is an isolation transformer? That's one where the primary and the secondary windings they're physically, electrically separated from each other. So the primary and the secondary, they're isolated from each other. And number 4, all values of a transformer are proportional to its the turns ratio. It's literally the number of turns on the primary versus the number of turns of wire on the secondary. And number 5, what is an autotransformer? So an autotransformer, unlike an isolation transformer, a autotransformer has only one winding, and that is used for both the primary and the secondary. Number 6, what is a disadvantage of an autotransformer? And no line isolation like there is in an isolation transformer. It's literally the same winding in an autotransformer. Number 7, the difference between step-up and step-down transformers. With the step-up transformer, like the name sort of implies, it steps up voltage. So the secondary voltage is higher than the primary voltage. And a step-down transformer is exactly the opposite. The secondary voltage is lower than the primary voltage. Number 8, so we have a transformer that with a primary voltage of 240 volts and a secondary voltage of 48 volts. And the question asks, what is the turns ratio of that transformer? So the primary voltage is 240 volts. The secondary voltage is 48 volts. 48 volts. And the turns ratio is the number of primary turns, so N is for number and P is for primary, versus the number of secondary turns, and that equals primary voltage over secondary voltage, and that equals 240 volts over 48 volts, and that yields 5. So the turns ratio is 5 to 1. Number 9, a transformer has an output of 750 volt amps. The primary voltage is 120 volts. What is the primary current? So we know with transformers, power in equals power out. So volt amps in equals volt amps out. And with this transformer, we have an output of 750 volt amps. That's output, so that's going to be at the secondary. And we know again, power in equals power out, so volt amps in equals volt amps out. So volt amps at the primary equals volt amps at the secondary. And we're given that value of 750 volt amps. And we're also given primary voltage of 120 volts. And now we basically have to use Ohm's law. So I'm not going to go through all the algebra here, but the primary current equals the primary volt amps divided by the primary voltage equals 750 volt amps divided by 120 volts equals the 6.25. Sorry for the bad writing here, guys. And number 10, a transformer has a turns ratio of 1 to 6. The primary current is 18 amps. What is the secondary current? And we have, basically it's a formula. The turns ratio, that's our 1 to 6, equals, so the number of turns on the primary divided by the number of turns on the secondary equals, again, sorry for the bad writing here, the current in the secondary divided by the current in the primary. Notice that the P is over the S on the ratio side, and the S is over the P on the current side. And if we do the algebra, we end up with secondary current equals primary current divided by, in this case, that's 6, this 1 to 6 turn ratio, and we get 18 amps divided by 6 equals 3 amps. Number 11, what do the dots on a transformer schematic represent? That's the polarity of the windings. So if you have, on the primary side, you have the dotted terminal, and when the voltage reaches, for example, its positive peak on that dotted terminal on the primary, the voltage on the secondary is going to reach its positive peak on its dotted terminal. Number 12, transformer has a primary voltage of 240 volts and a secondary voltage rating of 80 volts. If the windings are connected subtractive, what voltage would appear across the entire connection? It's subtractive, so it's literally, it's the 240 minus the 80 volts gives the 160 volts. Number 13, basically the same question, but this time it's a additive transformer. So in that case, it's 240 volts plus 80 volts. And number 14 is kind of a tough one here. The primary leads of a transformer are labeled 1 and 2. The secondary leads are labeled 3 and 4. And the polarity dots are on terminals 1 and 4. So which secondary lead would be connected to terminal 2 to make the connection additive? By the way, guys, 12 through 14 here, these questions, FYI only. These are not going to be on the final. Just wanted you to be exposed to it. So I'm going to try to draw this on the screen here. This is going to be the primary. I'm going to label this 1, this terminal is 2, and the question says there's a dot on the number 1 terminal. And then we have the secondary. I'm going to draw it like in the book. Try to anyway. This is the voltage that we're measuring here. This is trying to be a secondary winding over here, guys. So basically they want to know, what is this connection here? What is connected to terminal 2 on the primary? It's terminal 4. It's the dotted terminal. Sorry, I'm really trying to make that a 4. This is dotted, and this is 3. Sorry for the bad handwriting. Certainly send me an email if you have any questions on any of these problems.